Spark SQL is a different module, right? So which gives you a flexibility to process the structured data, yeah, in a distributed manner. This is an interface that provides more information about the structure of data and the computation being performed. Now you can interact with the Spark SQL in three ways. Simple Spark SQL, the plain Spark SQL. The another one is the Dataframe API and Dataset API. So this Dataset and Dataframe API dataset was introduced in 1.6.0 or 1.6.1, I guess. Don't remember the exact version, but it is 1.6. So this is a new API. Similarly, Dataframe is also a new API. Spark SQL is the old one, which was available. So we will try all these three APIs in order to process our structured data, right? So this is Spark is, the Spark SQL is actually a programming module, for processing this structured data. So it provides you an abstraction, so which is called as data frame or data set. So these data frame and data set are the abstraction for Spark SQL processing, to process the structured data. So let us talk about this data frame first. So data frame is a distributed collection of data organized into named columns. What it does, suppose if we have a data like this, ID, comma, name, comma, suppose country, we have got a few rows out of this, rows of like this, and want to create a data frame. This data frame will have the named columns. If this particular data set has a header also, the named column will have a header also. So the data frame information, the schema information will go like this, like the ID, comma, name, comma, country, and the data. So it will maintain the entire schema of your data. And now then you can query this data frame. You can query this data frame to process your data. You can also run the SQL-like query. So we have got three things. First is the data frame. First is Spark SQL, the core API for processing structured data, then data frame, and then data set. So we'll see all these three. So data frame is a distributed collection of data organized into named columns. It's conceptually equivalent to a table in a relational database. So it is actually equivalent to a table, right? Can be constructed from a structured data file. You can directly load a file and create a data frame out of that. Tables in Hive. You can create a data frame from the tables of Hive also. You can use some external database also, maybe Cassandra. So you can create the data frames from Cassandra database or from an existing RDD. So there are methods available which allow you to create the data frames from the existing RDD. So there are different ways to create a data frame. Either you can use the structured data file and directly load it into the data frame like sc.text file, or you can directly load a Hive table into data frame, or you can use some external database like Cassandra or HBase to create a data frame, or you can use the existing RDD to convert that into a data frame, right? So if I have to talk more about the Spark SQL, that's how the the architecture looks like. So at the top you have got the language, which could be Scala, Java, or Python, right? Moreover, you can use Hive also. So Hive is, you can use Spark engine. You can run Hive on top of Spark engine, right? So that's one part. That's one part. Another one is as part of this architecture only. We have got Spark SQL, which is again an API. Then we have got schema RDD. I'll talk about the schema RDD. We have got Dataframes and we have got datasets. All are these APIs? Different APIs of Spark SQL. Yeah, and here at the bottom you have got the data sources. So the data sources could be text files. You can simply load the text files, or it could be the JSON file, could be a Hive table, yeah, could be an external database like Cassandra or any other NoSQL DB like HBase. Yeah, so that is the these were layers in the context of Spark SQL. At the top you have got the language APIs, the languages, which can be Scala, Java, Python, or Hive, because you can use HiveQL also with this. Then in the middle we have got the APIs like Spark SQL API, Schema RDD, Dataframe API. This is not API actually. Dataframe API and Dataset API, right? And then you have the data source. So data source could be anything. It could be a text file, either a JSON file, or a Hive table, or some external database like Cassandra or HBase. Now, as part of Spark core, now I will talk about the schema RDD. What is the schema RDD is? For basic transformation and actions, we were using Spark core, right? And what is the basic level of abstraction for data? What was the basic abstraction for data in Spark core? Can you confirm what was the basic abstraction? Yeah, RDD. So RDD, on top of this RDD, there is a wrapper for Spark SQL, right? Which is known as schema RDD. That is one level up. Data abstraction for RDDs that are based on schema, which carries a schema definition along with this. But Spark SQL works on what? It works on schema. You talk about Hive, you talk about Cassandra, they all are working on schemas only, right? So we use the schema RDDs, to process the structured data, right? The SQL context is the entry point for all Spark SQL functionalities, be it data frame or anything else, right? Be it data set or the Spark SQL. So, like for the Spark core, we have SC as a Spark context, right? Similarly, for Spark SQL, we create the Spark context out of SQL context out of this SC only, Spark context only, so that the SQL context becomes the entry point for our Spark SQL related functionalities. Now, on top of the SQL context, there are other contexts available, like if you want to use Hive, primarily if you want to use Hive, if you want to use Spark SQL with Hive, you will create Hive context for that, so that you can run Hive queries directly from your Spark, right? How you create the SQL context? You get SC by default in the terminal. If not in terminal, then you create the Spark context out of the Spark context, and then out of this Spark context, you create the SQL context like this. So you say, well, SQL context equals to new org.apache.spark.sql SQL context, and pass the Spark context as a parameter here. Yeah. So remember that SQL context is the entry point for our Spark SQL functionalities, right? Now creating data frame. So using the SQL context, application can create a data frame from either from an existing RDD, or from a Hive table, or from some external data source, or by or from some external file also, like CSV file or maybe some JSON file also. You can create a data frame, right? So example, creating from a CSV text file. Use the provided CSV file on shell. Spark context is available. Create the SQL context. Okay. So let me create this. I should have this file available with me, so that I can we'll create our own data set. What it needs is the UH ID, location ID, doctor ID, bill date, service name. So let's take ID, name. So 1, John, US, 2, Adam, UK, 3, J, India, 4, Australia, 5, China. Right. Let's keep it like this. Let me save it as a CSV file. I'm going to store it under Spark Scala content, day 5 SQL datasets. Okay. So we have got the CSV file. Yeah. Now we can use this CSV file to create a data frame. So let us run the Spark shell first. Spark -shell. It's coming. Let me see what this presentation is saying. First, it is loading the file. So let me first create the context, SQL context for this, right? Say well, SQL context equals to, I have to import the packages too. Let me import the packages like this. Oops. Import SQL context underscore implicit and import org apache.spark. I'm not able to copy this. That is not being copied. What is this? SQL context dot implicits. Not able to find. Okay, this has been imported. Okay, no problem. I'll create my own SQL context then. SQL context equals to, then I can say new org.apache dot should be in Spark. Yeah, SQL and provide the Spark context here, right? So this particular, object now will be taking care of all your Spark SQL operations. No problem. Appreciation, no problem. But I've got this SQL context here. I'm using Spark 2.0, so generally, rather than the Spark context, we use Spark session here, right? You see, Spark session is available as Spark, and using the Spark session, you can create the Spark context. Okay. So now what we need to do next is, let's load this file. So say well my emp equals to sc.text file, give the location. Let me copy the location from here. Oops, it's quite long. Let me put this file, emp file, from here to this location, which is C Scala procs. Datasets and emp.csv. Yeah. So a file has been loaded in an RDD. I've got an RDD of that particular file. Yeah. What we are doing with the services then, case class services. remove the header from this particular file. Hospital data text equals to filter is not equals to header, right? Services T0. Okay, so let me now, I've loaded this file. Let me remove the header. Yeah, so I'm creating another RDD. Well, header equals to my MP dot first. So header has got the header here. Now I can filter out this header from my MP. What I'll say, I'll remove the names of these. Place them. Well, my EMP without header, right? Equals to my EMP dot filter, right? Equals to A not equals to header. Are you getting this? It is straight. Filter my EMP RDD, where the row is not equals to header, which is ID name country. It will filter and store that into the new RDD, which is my EMP without header. So it says not found value header. Okay, the spelling is wrong. It's head here. No problem. Let's use this only. So now if you look at this particular RDD, my MP without header, say collect on this, you will get the data without header here, right? Now let me create a case class for this. So case employees. Yeah. What should be there in this case class? I'm just providing the data type for my schema, right? So ID, let's take integer, comma, name, let's take string, comma, country, let's take, that's my case class. Case class name is employees. Now I'm going to map this case class to my fresh RDT, which is the RDT without header. Here this is, I think, done wrongly. It's not H data. There is nothing called H data here. Right. So let's have a new RDT. Well, my EMP schema equals to my EMP without header dot mapping it, splitting the data. This is comma, because comma is the separator in my file, right? And then mapping it for case class. What we are doing, this is my file. I have removed this from the RDD. Now in my fresh RDD, I've got this much data. What I'm doing, I'm parsing through this file, and taking every field as a column to match my schema. So I will use my case class here, right? So match P, okay, employees, right? Okay, and all right. So we'll take P. So there are three elements in this: 0, comma, P is nothing, just a variable, right? 1, comma, P2. Right, so it'll do. First split this, so you will get an array out of this transformation. Yeah. Then again use map on this. Take every element, take every row and map it to this case class like this. Just saying found string required integer where. Okay. So taking it as an integer. Okay, let me change my case class. Let me take string here. Again done it. We were taking the first one as the string. Now it's fine. Yeah. So I've got this my EMP schema. This is full of schema. Now this particular RDD has a schema here. Now schema attached to it. Now this particular RDD I can convert into the data frame directly. So I can say, well, my EMP df data frame equals to my EMP schema dot to df. So we convert that into the data frame. If it creates a problem, then I'll have to run it on VM because it might be looking for the Hive installation too. The problem that I'm getting here is, generally it happens when you run it on the local mode. When you create a data frame, by default, it looks for the Hive directory. What it's saying, Java lang runtime exception, the root scratch dir temp -sj should be writable, current permission this. So this is looking for the directory, although directory is available, but the permissions are not there. And since this is a window machine, I cannot change the permission like this, like the Unix system. That is why it is crying here, right? But that's how I'll be able to create a data frame, right? Let me do it on VM then. At least one data frame we should, right? That's how the internally data frame would be created. Else I can create a data frame in a single statement. I'm just trying to, make you understand that this is how the data frame actually internally created, right?
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.